Now, what we can do is I like to mark the high voltage and low voltage, the high potential, low potential side of each device. Okay, so for a battery, this is easy. That's a battery. Which side is the high potential side? Which side is the low potential side? The longer side is the high potential, always. Right, the battery, the long line on there is always at a higher potential than the short line. Doesn't matter which way the current's flowing. For a resistor, how do we know which side's at higher potential? We look at the current, exactly. Because current is the flow of positive charges. Remember, that's our convention. Current is the flow of positive charges. So if I have a current flowing this way, those are positive charges moving from left to right through my resistor. What direction do positive charges go? They go towards lower potential, right? Positive charges want to go down the potential hill. So if the left end is at higher potential and the right end is at lower potential, that means positive charges would go that way, like is happening, right? If it was the other way around, positive charges would not be going that way. So if we know the current is going left to right, then the left side of this resistor must be at higher potential than the right side, or the current wouldn't be going that way. Current is the flow of positive charges. Positive charges flow towards lower potential, down the potential hill. Question?
I'm a little confused about how we're defining the section coming out of the bottom of battery 2 there. Why we're not defining that?
Oh, this is right in here.
Yeah.
This would be I2. And it doesn't change once it comes out of this junction. It goes through battery 2 and then through resistor 2, and it can't change until it gets to another junction. Thank you. All right. So now that's what we're going to do right now is mark the high and low potentials. So I'm going to use I'll use blue here. So my batteries, that's pretty straightforward. I've got a high and a low. My resistor, then for R1, the left side would be at higher potential than the right side. For R2, the bottom would have to be at higher potential than the top because the current's going up through R2, we're saying. And for R3, the bottom would have to be higher potential than the top because the current is going up through R3. I think I got everything. All right, so now we have to apply the junction rule. So we pick a junction, the one at the bottom or the one at the top. Does it matter? Let's do them both. See what happens. I'll call the one at the top junction A, the one at the bottom junction B. Junction A says the sum of all the current in, what's going in? I1 plus I2 plus I3. Has to equal what's coming out, which is 0. Okay? If we had picked the other junction, what would we have gotten? What's going in? Nothing. What's coming out? I1 plus I2 plus I3. The exact same equation, right? So those two junctions are identical. So pick one of them. Don't pick both of them. Get the same equation again. Okay, so we have a junction rule. I'm just going to highlight one of them. That's our first equation. Now, how many equations do we need? We need 3, right? Because we have 3 unknowns. We're missing I1, we're missing I2, we're missing I3. So 3 unknowns means we need 3 equations. So our junction rule is always the first equation. And now we can apply a loop rule, but we have to do it twice because we need 3 equations. So there are actually, in this circuit, there are actually 3 loops you could use. You could go from B to A and then back to B through this middle leg. That's one loop. You could go from B to A and around through R3. That's a second loop, right? So there's a loop over here on the left. There's a loop on the right. And the third loop is the outside perimeter. Right? There's 3 loops there. Let me tell you, if you use those 3 loops and you do not use a junction, and you say, hey, I've got 3 equations, I'm going to solve for my 3 i's, you know what's going to happen? You're not going to solve for your 3 i's. You're going to get down to the end and you're going to get 1 is equal to 1. Because one of these loops, once you've used 2 of them, the third one contains no new information. It's already included in the other ones. So if you've got the first loop, it includes the 2 batteries and 2 of the resistors, right? The second loop incorporates the other resistor. The third loop has nothing new in it. So it's no new information. So that's really only 2 equations, and you're never going to be able to solve for 3 things with 2 equations. So you always have to start with the junction rule first thing, and then fill in with your loop rules. And as you do your loops, make sure each loop gets some new information. Okay? Maybe you could even do it this way. Start here and do a loop through the first path. That's your first loop. And then start here and go through the longer path. That's your second loop. Then you know they're going to be a little different. You know you're going to have new information. All right, so let's do 2 loops. Which should we do the left and the right, the 2 small ones? Not do the perimeter? So I'll sort of draw this one in, oops. We're going to pick a starting point and pick a direction. Because it matters what direction you go. Okay, so there's our starting point, there's our direction. So now we're going to write the sum of all the potential rises and drops has to be 0. So what's the first thing I do if I'm starting in this lower left corner and I start going around the circuit? The first thing that happens is I get to the battery. And I go in the low side and come out the high side, so I have risen by the voltage of the battery. So I've gone up by V1. Good? Now, that's why I put the pluses and minuses there. Now I keep going, and I'm going in the high side and coming out the low potential side, so I'm dropping by a voltage that's across that resistor, R1. How much voltage drop is there across a resistor? I times R, right? V equals IR for a resistor. So this is going to be, I'm dropping now by I1 times R1. You have to be careful with your subscripts here. This is I1 that's going through that resistor, and it's called R1. So far, so good? Now, I keep coming along, and I get to R2. And I'm going in the low side, and I'm coming out the high side. So I'm actually rising in voltage as I go through R2 because I'm going against the current. So this is a rise of I2 times R2. So I go plus the current in that resistor times the resistance, I2, R2. So those are different I's and different R's. You got to be careful with your subscripts. Then what happens? Then I get to a battery. And I go in the high side and come out the low side. So I am dropping by that voltage, V2. So this is a battery. And now I'm back to where I started, right? I keep walking along, and I get right back to where I started. There's nothing else there. So you want to remember, don't think a battery is always a rise and a resistor is always a drop. It depends what direction you're going through your circuit. So we saw in this case, a battery could be a rise, like V1. I had plus V1 here. It's a rise. Or a drop, because I went the wrong way through V2. It's a negative V2. And a resistor could be a drop if you're going with the current, or a rise in potential if you're going against the current. So that's why the little plus minuses help. Okay, so there's our, that's our second equation. The junction rule was our first equation. Here's our second equation. And then we need another loop. We'll do the right loop. And we'll use, how about purple for that? So pick a starting point, maybe this corner, and we'll go around this loop in that direction, in the clockwise direction. Okay, so what's the first thing we hit? We're walking along. We hit V2. We're going in the low side, coming out the high side. So we have gone up. We rose plus V2. Then we hit R2. We're going in the high side, coming out the low side. We are dropping in potential. So the current through that resistor times its resistance. And we keep going around, and we get to R3. We're going in the low side, coming out the high side. So that's a rise. Plus the current through that resistor times its resistance. And I think that puts us back to where we started. Yeah, there's nothing else. So those all have to add to 0, and that is equation 3. So we have 3 equations and 3 unknowns. We plug in everything we know. We know the R's, we know the V's,